Hello, Abby. How are you doing?
Hi, sir. Yeah, I'm good, thank you. How are you?
Very good, very good. So at school, which topic are you doing these days?
So we're doing sequences and series with one teacher, and then another teacher. It's proof by contradiction.
Okay.
But I feel like I'm kind of struggling with both. I think for now, because the bigger topic is the sequences and series.
Okay.
Do you think we can touch upon a couple of exam questions and then
Sure.
work from there? I guess.
So you share whatever questions you have, and let's try to see how do we solve them. Okay.
Okay. Yeah. So I got a couple. I mean, I think this is quite a big document, so we can just go through randomly because, yeah, I don't know.
Can you read this question number 1, please?
So a farmer has a pay scheme to keep fruit pickers working throughout the 30-day season. He pays £8 for their first day, A plus D pounds for their second day, and A plus 2D pounds for their third day, and so on, thus increasing the daily payment by D pounds for each extra day that they work. So a picker who works for all 30 days will earn £40.75 on their final day.
Correct.
Part A, use the information to form an equation in A and D.
Correct, right? So it is basically arithmetic sequence, correct? So he pays A pounds. So it starts with A pounds. And then the next day, he pays A plus D pounds.
Yeah.
So that is a payment being done in pounds, right? Yeah. I'm so used to writing dollars.
All right.
Okay. And then A plus 2D. That means each time it is increased by D pounds, correct?
Yeah.
So when
Plus D.
In a sequence, the rule is that add a fixed amount. In that case, it is an arithmetic sequence, right?
Right.
So each time it is increased by D pounds. We now want to use this information to form an equation in A and D. So basically, if you have to find a general term, let's say this is your term number 1, when you have A pounds, then term number 2 has A plus D, and 3 has A plus 2D. You will see D is 1 less than 3, right?
Right.
So the nth term, let me write Tn, will be A plus n minus 1D. Is that okay?
Yeah.
So that becomes the equation, right? A picker who works for all 30 days will earn 40.75 on the final day. So on the 30th day, the earning is 40.75. That's what they're trying to say, right?
Yeah.
But anyway, part A is use this information to form an equation in A and D. So that becomes an equation in A and D where Tn is earning on the nth day, right?
Yeah.
Okay. Now, a picker who works for all 30 days will earn a total of how much it is? Can you read?
£40.75.
No, what is this? Okay, this is the next question. Okay. 40.75. 1,500, right? Okay, that is the next part. So first part is a picker who works all 30 days will earn 40.75 on the final day. So Tn is 40.75. So you can use your calculator to do the calculation. So 40.75 is equal to A plus n
29D.
We can write 29. Okay. So that becomes the equation which relates A and D, right?
Right.
So we get part A. Now, can you please read this part, what it is?
So a picker who works for all 30 days will earn a total of
1,005. So the sum, that means the sum for an arithmetic sequence is number of days divided by 2 times
2A.
2A
plus n minus 1D.
N minus 1D. So that's the formula, right? Now it says the picker who works for all 30 days, so n is 30 for you, and total is 1,005. So we have 1,005 is equal to 30 divided by 2 within brackets twice A, n minus 1 is 29 D. So that becomes your second equation. So as you can see, we have two equations and two unknowns.
Oh, so we can cancel
You can
one
easily
simultaneously.
solve, right? Now part C is hence find the value of A and what?
Sorry.
Yeah.
Can you see this?
Yeah, I can see that.
Oh, that's really annoying. I don't know why it's there.
It doesn't matter. Doesn't matter.
Sorry.
So now you can easily do it, right? So we can actually divide by 2, simplify this second equation. We can write as 10/5 equals to 15 times 2A plus 29D, right? Now, you can replace 29D by 40.75 minus A. Is that correct?
Oh, yeah. So you can get all this.
Yeah. So we'll get, you can do the calculation 2A plus, now 29D is 40.75 times minus A, right?
Mm-hmm. Minus A, yeah.
Now you can open the bracket. So 2A minus A is only A, right? So we get 1005 and equals to, we can say 15A plus 15 times 40.75, right?
Yeah.
Now divide by 15, everything.
Could I just get my calculator quickly?
Yeah.
Sorry. Thanks.
1005 divide by 15. They're given very good figures, so we can easily do it now. So divide by 15 will give us 67 equals to A plus 40.75, right? So A will be equals to 67 minus 40.75. So minus 40.75 is 26.25. You get the idea?
Yeah, 26.5, got that.
26.25, right?
Oh.
Yeah, 40.75 it was. So you may check the calculations. However, I think you have understood the method, right?
Oh, sorry, that was my bad. Yeah, 40.75, yeah.
So a method is absolutely clear. We know it's an arithmetic sequence since every day D extra is being given. So we use the sum formula and the general term formula to find the value of A first. Now you can substitute the value of A and find D, correct?
Right.
So you can do that part. So D will be 40.75. I don't have much space here, but you can write D equals to
minus
40.75 minus 26.25 divided by 29.
Divided by 29. Yeah.
Everything divided by 29. Is that clear to you? So
yeah.
You can find what this is. That's simple. Let's do it.
So it's all just about using, so it's 0.5. D is 0.5. So it's just about using the formula. So in this case, it was just knowing the formula and subbing the values in.
That is so true. So we got the value of D is 0.50. Is it okay?
Yeah.
Now, whenever it is currency involved, use 2 decimal places.
Oh, right. Okay.
So I think that's clear. Take a picture of this and then we can move forward.
Yeah, I can screenshot it on the computer.
Okay, sure.
It's a new feature. Cool.
Yeah.
Thank you. I did it.
Okay, so we'll clear this. What is the next question?
I'm going to scroll down a bit because I feel like that could be similar to that one.
Okay, your wish. Anything.
Because I don't want to do easy ones. I'm going to do some hard ones.
We can cover them all. Don't worry. We can cover.
You sure? All.
Yeah.
Okay. I think this one looked kind of hard.
Okay.
Only because of the wording, and then I can scroll down.
Yeah, you can read the question and then skip, right?
Yeah. Okay. So Jill gave money to a charity over a 20-year period from year 1 to year 20 inclusive. She gave £150 in year 1, £160 in year 2, £170 in year 3, and so on. So that the amounts of money she gave each year formed an arithmetic sequence.
Yeah.
Part A. Yeah.
We can skip it. Yeah. Move to the third question. Similar.
Okay. I feel like these are all similar, but I think when I get to question 10-ish,
okay.
we
read
can.
it. Yeah. Okay.
Oh, I feel like Sarah is the same, that's why.
Okay, skip. Don't worry.
Okay, yeah, this one.
Your wish, yeah.
Thanks. Okay, so Anne has some sticks that are all of the same length. She arranges them in squares and has made the following 3 rows of patterns, row 1, 2, and 3. She notices that 4 sticks are required to make the single square in the first row, 7 sticks to make the 2 squares, and then in the second row and in the third row, she needs 10 sticks to make 3. Okay, so it's plus 3. Yeah. Find an expression in terms of n for the number of sticks required to make a similar arrangement of n squares in the nth row.
Okay, I'll teach you a very good method of finding the value of n without using your standard formula. Your standard formula is the nth term is equals to a plus n minus 1 times d. Is it okay?
Yeah.
So if you use the standard formula, you get 4 plus n is n, so you get n minus 1, and d is 3 for you, correct? And then actually you simplify this. You get 4 plus 3n minus 3, right? And then you get 4 minus 3 is 1, and you get 3n plus 1. Do you see that? You have to do all these steps to get to this formula. Now let me teach you. I'll take you back to linear equations. Let's go to, if we are getting the next term by adding 3. So what was the previous term? Minus 3, right?
Right.
So if I go back here, minus 3 will give me 1 for 0. You get the idea? So initial value is 0. That is my like y-intercept for a line. You understand? When we talk about arithmetic sequences, we are trying to put all the points and they will all be in a straight line, correct? So this basically, if you understand the concept, really means what? It means that we have a straight line where we are given these points. You see that? These points. If I go back, in that case, I actually find the point which is a y-intercept. And therefore, I can write that this term number can be given to us with the slope, which is 3 in this case, right? N plus the y-intercept, which is 1 for me.
1. All right.
So I get the same result, which is Tn equals to 3n plus 1 without doing so many steps. You get the idea.
All right. Yeah.
So now the thing is, you do have marks for the steps also, right? But in case part A is, well, in this case, part A is 3 marks. So you have to do all these steps, correct? But anyway, it's a good idea to check like this. Perfect?
I see. Yeah. Very
good, right?
Yeah, and you did it really quickly.
Yes, it's like one shot, right?
Yeah.
Yes. Now, next part.
So Anne continues to make squares following the same pattern. She makes 4 squares in the 4th row and so on until she has completed 10 rows. Find the total number of sticks that Anne uses making these 10 rows. Okay, so basically we want to find what is S of 10, right? Yeah. S of 10. And so we can just use the formula, which you know, right? So it's just 10 over 2. I'm writing it straight here, right? Yeah. And twice, the first term is 4 for you, plus n is 10. 10 minus 1 is 9, and d is 3. And you can calculate this. Is that okay? Yeah. So 5, 8 plus 9 times 3, 27. 175. You got the answer? Yeah. I just used a calculator. What is the answer? 175. Perfect. So that is your answer for the number of sticks required for 10 rows. Is that clear? Right. Yeah. Okay, great. Next part. This part. So Anne started with 1,700. Okay, let me erase this and we'll write the key information here. So the key information is that we have got the nth term, which is equals to 3n plus, what was it? 3n plus 1, right? Yeah. Okay. Yeah. And we have the value of a, which was 4 to us, and the value of d is 3 for us, correct? Yeah. Okay, yes, let's continue. So Anne started with 1,750 sticks. Given that Anne continues the pattern to complete k rows, but does not have sufficient sticks to complete the k plus 1th row. Part C, show that k satisfies 3k minus 100, k plus 35 less than 0. Perfect. So basically, maximum gives you the total, right? So the total
cannot exceed 7. So total formula is Sn, as you know, is n over 2 times 2a plus n minus 1 times d. Right? That was our formula, right?
Yeah.
Now, she has 1750 total, right? So this number has to be smaller than the total which can be used in kth row, right? This number has to be bigger, right? So this number has to be greater than or equal to. Exactly, we can do those many, correct?
Right.
For using the kth row. So n becomes k for us, right? So k over 2 times 2 times a is 4 for us. 2 times 4, let me write.
Yeah.
Plus k minus 1 and d is 3 for us.
3.
Okay, let's try to solve this. You can multiply by 2 this side. So 1750 times 2 is how much?
3,500.
Greater than k times, within brackets, you get 8 plus 3k minus 3. So open the bracket. So we get 8 minus 3 is 5, right?
Yeah. Plus 3.
And plus 3k squared. We get a quadratic equation. You see that? Take it on this side. So we get 5. Let me rewrite this as 3k squared. Quadratic equation, write in proper order.
Yeah.
5k minus 3500 is less than 0. Is it clear to you? So we brought all the terms together on one side. You have a quadratic equation. You need to factor. So we are looking for a product of 3 times 3500 and sum to be 5. So let's try these values. You get the same result. So let me write straight away this 3k minus 100 times k plus 35. Does it make sense?
Yeah, I got the same results.
You get the same result, right? So when you factor this out, you can always get this result as shown here, right? Now I'll tell you, if they normally do not give you the result, how do we do it, right?
Yeah.
Let me tell you that method. So 3 times 3500 is what?
Let's do it. 331 times 3. 10,500.
Do square root of that. What do you get? Use calculator. Do square root of
10 root 105.
Decimal value.
Oh, sorry. 102.46.
102.46. That means the factor of 3500 close to 102 will work for you. You get the idea. So the factor is 100. So we will split 100. We will write this as 3k square plus 100. If I do that 100, so what is the other factor? 35, right? So we are looking for the number which is only 5 different, right?
Yeah.
So so if one number, so what is this number? 3 into 3500?
10,500.
Divided by 100. So if you divide that by 100, you get 105.
Divide by 100. Yeah.
You see that? So you can split 5 into 2 terms, which are 105k minus 100k. Minus, you're getting my idea, right? So 3500 less than equal to 0, right? And now you can factor these two and those, two. That term.
Right.
So what I'm trying to show you here is that, well, because the answer is given to you, right? We could straight away go from here to there. However, if it is not given to you, and if you have to factor, this is a neat technique. You see how I got the number 100?
Yes, yeah.
Because there are so many factors of this 3 into 3500. We have to get the right one in the test.
Yeah.
How do we get it?
Like that.
Yes. Or you can use the quadratic formula and factor, right? So you know quadratic formula. So you can say n equals to minus b plus minus square root b square minus 4ac over 2a. So these are the alternate methods. Let me write down alternate methods. To find factors, correct? Does it make sense to you?
Very clear.
Very fast. And then you get the same result. And as you can see, we have got the correct answer. That is how you're going to do it. 4 marks.
Nice.
Part D is find the value of K. So just find the value of K. Of course, K cannot be negative, right? K has to be positive. So
Positive.
you will use this 3K minus 100, right?
Over 3.
So we get 3K. Let me use different ink now. So we get 3K equals to 100. So K is 100 divided by 3, right? So when you do that, you get 33, right? As a whole number.
Recurring. Yeah.
Leave the rest because that is the maximum value. Is that
right?
correct?
Yeah.
So we can make 33 patterns with this number of sticks.
So do we not need? So we don't need to use any like. So that's the K plus 1th row, right?
Yeah.
Okay.
So the sticks to the thing is that you can complete K rows. You can complete K rows, correct? Find the value of K. So you complete 33 rows. For the next row, there are some which are missing. Is that clear?
Oh, I see. Yeah. Okay.
But this is a very standard question, which has been asked so many times in the test paper with different values.
Right.
So actually, I'll share with you because I was looking into many questions which have come in previous test papers for you. So I looked into a couple of them, and I found that this kind of question is very, very popular. So here are a few questions which are there. Can you read this question on the screen for you?
Oh, sorry, I need to stop sharing.
Okay. You stop sharing, then I'll share my screen.
Yeah, I see it.
Can you see it now?
Yeah.
Okay, great. So let me just enlarge this a bit. Can you please read this question?
So matchsticks
pattern.
Sorry, there's a the thing that was on my screen. It's on yours now, so I can't see.
Oh, I see. Okay. So let's let me stop sharing this first. Now I'll share it again.
I feel like it's my thing.
Yeah, it may be now. Is it okay now?
It's still there. No. I just can't see the matchsticks pattern is shown, and then I can't see.
Just one line, right?
Yeah.
Can you see it now?
Oh, yeah. Now I can see.
Okay.
Shown in the figure.
Yeah.
Cool. Matchsticks pattern is shown in the figure. 6 sticks are required to make the first, 11 for the second, and 16 for the third pattern. Part A. Write an expression t to the power of nth term. I don't know how to say it. Tn. For finding the number of sticks required for the nth pattern.
Correct. Continue, Ricky.
B. How many sticks will be required for the 50th pattern? Part C. Show that the maximum number of completed patterns with 1029 sticks can be represented by the inequality 5n minus 98, n plus 21, which is both less than or equal to 0. Correct. And then finally, part D, find the maximum number of patterns that will be created with 1029 sticks.
Exactly similar to what you shared.
What I said, yeah.
You see? So
same layout as well.
You have to follow the same method, right? And so starting with your T pattern, so that you know how many sticks. You started with 1, 2, 3, 4, 5, 6, right? First is 6. And second, they have given already 11. That means you're going up by 5, correct? So if part ABC, if we ignore the method required, then this will be what? 5 less, right? For 0. So I have Tn as 5n plus 1, correct? Simple as that. And we have Sn formula, and the value of Sn is 1029, correct? And this 1029 has to be greater than or equal to all that, correct? And then you just simplify and find your solution. Is that clear to you?
Same method, yeah, process.
So that is how it should be. So I'll stop sharing this, and now you can again continue from where you were, right? So you can again share your screen, and then we'll continue from there.
All right. So yeah, that's a very popular then, since the layout and everything.
It will come in your test.
So I'll keep that in mind.
It will definitely come in your test. So therefore, mark it and understand how do we do it here. Next question, please.
Oh wait, yeah, I should mark it. So what question was that? 8. Okay. must. I feel like I need a list of all those questions that would come up.
Yeah. Can you please read this one, 9?
An athlete prepares for a race by completing a practice run on each of the 11 consecutive days. On each day after the first day, he runs further than he ran on the previous day.
Mm-hmm.
The lengths of his 11 practice runs forms an arithmetic sequence with the first term A kilometers and the common difference of D kilometers. He runs 9 kilometers on the 11th day, and he runs a total of 77 kilometers over the 11-day period. Find the values of A and D.
Correct. So he runs 9 kilometers on the 11th day. So the term number 11 is 9, right?
Yeah.
And he runs a total of 77 kilometers over. So S of 11 is 77. Is that clear to you? Right?
Yeah.
So we know how to solve these types of questions. They are very easy to solve. We know the formula. So we say T11 is basically equal to, what is this? A plus
10D.
10D. And S11 is basically equal to twice, first we do N 11 by 2. I wrote 11 by 2, right? Twice A plus N minus 1D is 10D. Is it okay? So we have this as 77, correct?
Oh, yeah. Yeah.
And the other one is 9. Is that clear?
Yeah.
So you can see from the first equation that you can write 10D is equal to 9 minus A. Is that okay?
Oh, and then sub it in.
Sub it in here, right? So you get 77 equals to 11 over 2, 2A plus 9 minus A. Do you see how easy it is?
I don't see that.
By 2. Nobody sees it. I'm telling you.
I've never seen that before. Obviously the classic one is to multiply out both and then just simultaneously solve. That's so easy.
Simultaneous equations and sequences and series. See, sequences have a pattern. So your solutions should have a pattern, correct?
Oh, that makes sense.
These 4 or 5 types of patterns, if you know, you can solve every question based on sequences and series. Okay.
All right. Yeah. I didn't think that something with a pattern the solution should also have a pattern. I didn't know.
Of course, right? So it makes sense, right? So we have A plus N. So now we are setting up this pattern. We know we just multiply that 77 by 2, right? Because 11 is odd number, simple as that. And so we got that. And within the bracket, A plus 9, open the bracket now. So we get 154 equals to 11A plus 99, right? So 11A is equals to 154 minus 99, right? So which is as good as take away 100, add 1, right? So if you take away 100, add 1, you get 55. So A is 55 divided by 11, which is 5. And now you know A. So D is equal to 9 minus 5 divided by 10, correct?
Yeah.
This is 4 divided by 10, which is 0.4 kilometer.
Right.
So we got both A and D, right? So we're starting with 5 kilometers, right? And we do 5.4, right? Like the 5.8 and so on. Is that clear to you?
Right. Yeah.
So that becomes your pattern. Clear?
Yeah. So that was 7 marks.
Yeah. And we did it in few minutes. Do you see that?
They say in maths that it's like a minute per mark or something. So yeah, it's supposed to be 7 minutes. Yeah, we beat that. It was like 3. I don't know. It was really quick. That's what I'm trying to say. Yeah, so I think we're getting the gist of these ones because they're arithmetic. Do you think we should move to geometric? Because I got a couple more here. We can always come back to it.
Yeah, sure. Geometric. Let's look into geometry. Sure, yes.
So these formulas and stuff, they don't come in the exam. You just got to know them, right? Like the sine and cos.
The standard formula, right? The arithmetic series, geometric series formulas are very standard. I mean, easy to remember also. And if you forget them, it's easy to derive also. It's not a big deal, you know? Yeah, okay.
That's true. Yeah. Just double checking. Okay. So
log thing is scary, right? Whenever you see log, it is kind of scary. So let's do this question. Can you please read it?
Yes. Okay. So the adult population of a town is 25,000 at the end of year 1. A model predicts that the adult population of the town will increase by 3% each year, forming a geometric sequence. show that the predicted adult population at the end of year 2 is 25,750.
Yeah, find the second term, right?
Yeah. So this is geometric. So it's ARN minus 1.
So R is
ARN
0.03 to the power of 1. Is it okay?
N,
2 minus 1, right?
Wait, is it N minus 1? Oh, yeah, it is.
2 minus 1. Let me write 2 minus 1 if you want to, right? 2 minus 1 is 1. Is it okay? Okay. And R is 3%. That means 3 divided by 100. And just use your calculator. No, 1 plus. Oh, sorry. 1 plus. I should have written. Wait. I wrote a wrong formula. Wait. Sorry for that. I should have written plus that, right? So let me write just the formula first, right? A times 1 plus R to the power of N minus 1. That is the sum, right? Oh, sorry.
I thought it was AR N minus 1.
Yeah. So Tn equals to A times R N minus 1. I'm getting confused with Tn and Sn. A times.
That's right. Yeah.
Minus.
It's easy to get them a little bit modeled, but I think after you do a couple, maybe. And
correct?
Yeah.
So that is your formula. You can plug in the value and find the term second year, right? Simple as that. Just multiply the A term with, when they say show that.
So is A 25,000?
Yeah, A is 25,000.
Cool. R is 3%, so 0.03.
Yeah. So 1 plus that. Initial value plus that much. So this will give you increase. The model predicts that the adult population for the town will increase by that much. So initial plus that much. Is that okay? So T2 will be T1 plus A R to the power of N minus 1. Thanks.
Yeah.
So we'll add 750 to it, right?
So 25,750.
Yeah.
So when we figured out the 750, was that just in year?
So 750 is the increase. So because the question is, the model predicts that the adult population of the town will increase by 3%, right? They're not saying it will be that much, correct?
Yeah.
So only the incremental thing is given to you, right? So we are given the term A, and then we are saying the next term is AR, but we are given the difference between the two, increase by, incremental change. You get the idea, right?
Yeah. That makes sense. Okay. So question part B, write down the common ratio of the geometric sequence. So
you divide one by the other, right? So R will be equals to 25,750 divided by
25,000.
Yes.
So 25750 divided by 1.03.
Yeah, 1.03, right? So that is how the geometric series, each term will be increased by. Is it okay?
Oh, so now if I did the same thing that we did up there, would I get 25,750 straight?
Yeah, if this is the value of
1.3. Okay.
Yeah.
Oh, so I could have done it straight, because when I saw increase by 3%, I know that is the multiplier is 1.03.
Yes.
Yeah. Oh, sorry. That was my mistake.
No, that's correct. But you have to understand the concept.
Right.
So can you summarize what did you learn from here? Can you summarize that?
Yeah. So I learned that. So I kind of jumped to conclusions here, and when I saw 3%, I just put that as R, so 0.03. But it's because it says increase here. It means that what the value I got was 750. That's the increase. So that's not the actual ratio R. So from that, you have to add the initial, which was in year one, which was 25,000. And so that's how we got the 25,750.
Right. So let me summarize here. This R is different from that R. You get my point? Right. This R is the geometric series R. So what we normally say is that there are two terms which we have to look into. I'm not sure whether they can ask it in a different question. One is growth factor. And another term is growth rate. At which rate is it growing? You understand?
Okay.
So the growth rate is 3%. The growth rate is 3% and growth factor is 1 plus 3%. You are multiplying by 1.03 each time.
Right.
Correct? So many times we also ask students this question. In this situation, what is the growth rate? What is the growth factor? You get the idea?
Okay.
So I could have told you that the geometric series is 25,000 and the next term is 25,750. Is it okay? You can find the value of R, which is 1.03, but my question would be, what is the growth rate? What is the rate at which it is growing? 3%. Yeah. That is what is one. You get the idea of now of both the things. You get the sum of it, right? You see.
So when you see factor, it's something that you're multiplying by. But if it's a rate, it can be as a percentage or something.
Correct. So rate is the rate at which it is growing. Do you see that growth rate? 3%. So it's a very important question from application point of view. Most of the time, all the applications will use this language. Normally, when you are doing geometric series, you are given the series, right? So you knew what exactly R is, correct?
Yeah.
Here, R is interpreted in two different ways. It could be growth rate, it could be growth factor. Both are different things.
Yeah, that's why I nearly got that question wrong. Yeah.
Good.
Because they're different.
No problems. Now let's look into the next part. What is that?
All right. So the model predicts that year end will be the first year in which the adult population of the town exceeds 40,000. Okay. Part C, show that n-1 log of 1.03 is greater than log of 1.6.
Correct. So now you have your equation and it says the town predicts that year n will be the first year in which adult population of the town exceeds 40,000. So we have to now find the term, general term Tn, right? So that term is, you can use this now formula, which is your geometric series formula. Is that okay?
So yeah.
The first year is 25. The second year is n-1, correct? But the growth factor is 1.03. And therefore, you will say that 25,000 times 1.03 to the power of n-1, that exceeds 40,000. Is that clear to you? This becomes your equation. You have to solve this, right? Can we solve it now?
Yeah. Is that why they use log? Because it was
log. Like, so first you divide 40,000 by 25,000. What do you get?
You get 1.6.
Right. So now you get 1.6. Do you see that? So divide this, right? So you have 1.03 to the power of n-1 is greater than 1.6, correct?
6, yeah.
And now you take log on both the sides. So n-1 log of this. So we get we get the same equation, right? Let me use a different ink. It becomes messy. Okay, so so you get the same equation when you take log on both sides.
And the same equation is what?
And you'll get the answer.
Oh, yeah. Oh, okay. So the exponent of n-1 just comes down because that's a log rule.
Okay. Log rules.
Yeah.
Take log and apply the rules, right? And you get your answer. Is that clear to you?
Yeah. Oh, that's not that bad. Every time I see log, I start stressing, but that's okay.
So you take a snapshot of this and then we'll move on to the next question.
Yeah.
I'll clear the screen.
Got it. Okay.
Yes.
Finally, part D. Oh, it's a long question. Part D.
Yeah.
Find the value of n.
Correct. You can solve this equation. Is that okay?
By just taking log on the other side.
Log you have already taken, right? So you find the value of n. The only thing is this should be greater than that. Now divide by log of 1.03.
Yeah.
N minus 1 is basically greater than log of 1.6 divided by log of 1.03. Correct? Do this.
So when I do this, can I take the base as 10?
Yeah. Base is 10. Yes.
Okay. And then plus 1. Yeah.
And then you plus 1. Yeah. So n is greater than 1 plus this value. Is that clear to you?
Got it. Yeah.
Okay, great.
Final part. So at the end of each year, each member of the adult population of the town will give £1 to a charity fund. Assuming the population model, part E, find the total amount that will be given to the charity fund for the 10 years from the end of year 1 to the end of year 10, giving your answer to the nearest £1,000.
Correct. So as you can see, the function basically is an exponential function which is kind of growing, correct? So you can use your formula to find the answer, right? So you know the first thing you have to find how many people will be there in the 10th year, right?
Yeah. So do I use that formula?
10, yeah. You know 25,000 is a value, correct? And
but is it SN? Are you doing the sum one?
Yeah, sum, because you need how many people will be there, right?
So if I was about to do the TNAR n minus 1 one, what would that give me?
Sorry. Find the total amount that will be given to the charity fund for the 10 years from the end of year 1 to the end of year 10. So every year, you can find the terms. Every year they're giving £1. Do you understand?
Okay.
So let's say first year, they will collect 25,000 pounds.
Yeah.
So first year will be 25,000. Let me write K for 1,000, right? Second year, 25.750, correct?
Oh.
K.
Yeah.
So you have to add each one of these values, correct?
Oh, I see. Yeah.
You have to add all of these values for the 10 years.
10th year. That's why you use that formula.
That's why I straight away used this sum.
Yeah, because that's why I was asking. Okay.
Yeah.
Got it.
So basically, you can do that. I mean, you have to do the sum ultimately, correct?
Yeah. So it is kind of pointless trying to. No, I just wondered if I did do it straight to 10, does that just give me 750 then?
Can you please read the question once again?
Yeah. So find the total amount that will be given to the charity fund for the 10 years from the end of year 1 to the end of year 10.
Correct.
Giving your answer to the nearest 1,000.
Perfect. You understand? So at the end of year 1, it will be 25,000 pounds. Is that clear to you?
Oh, okay.
At the end of the year 2, it will be 25,750 pounds.
750. Oh, okay.
At the end of 3, that much. So every year they have contributed.
Yeah.
All these will sum together at the end of 10 years. So straight away, we can find what is the sum of the numbers for 10 years.
Right.
And those many pounds, because it's £1 each. If it was 5 pounds, you'll multiply by 5, the whole thing.
Yeah.
1 pound multiplied by 5. 1. And you get your answer. Is that clear?
Got it.
So this is done. So you understand how to do it, right? So this is application based on geometric sequence.
Right. Makes sense.
Yeah. Next question, that'd be the last question for us.
Oh, okay. Do we still want to do it from this section or from this page?
Same section. Anyway, any question you want. It's your class.
Oh, okay.
It's class for you. Yeah.
So it's very personalized. Thank you. Okay. Let's pick one. I haven't actually. Oh, let's do this.
Okay, sigma. Let's take sigma 1, right? So there'll be a variety. Can you please read question number 5?
So a sequence A1, A2, A3, and so on is defined by A1 equaling K and A n plus 1 equaling 3A n plus 5, where n is greater than or equal to 1. Part A, write down an expression for the second term, or a to the power a to 2, in terms of k.
Yeah, so right now, so we have a1 equals to 3, right? A2 is equal to 3 times an, right? So we are, that means a1, right? So I'm writing 3 times k plus 5. Is that clear to you? We have used this formula. So a2, or you can write like this, a2 is equals to 3 times a1 plus 5. Is that clear? And a1 is k. So we'll write a 3 times k plus 5.
But could you, so I see what you did there, because you subbed in, so a1 you subbed in as n, so 1 plus 1 is 2.
Yeah.
But could you go directly to it by doing, what is it, that
n
formula?
plus 1, n plus 1 means n is 1, right?
Yeah.
So it becomes a2. When you write a2, a2 basically means 1 plus 1, right?
Oh, yeah, yeah.
So which is equals to 3 times a1, right? Because that is an. N is 1. Is it clear to you?
Right, yeah.
So we did this for n equals to 1. So we found n plus 1, which is a2.
Yeah. And then we got a1
known to us as k, and we got your formula.
So 3k plus 5.
So,
okay. So show that a3.
now this is linear. Let's be very clear. This is linear, and therefore we are talking about arithmetic series. Do you see that term? 3k plus 1. K is constant, right?
So are all linear sequences arithmetic?
Yes.
Oh, so all quadratic sequences?
No. We'll see the exponential. Those will be exponential, right? So
okay.
This is constant factor. So this is linear, right? 3k plus 5.
Yeah.
Okay, now let's do the next one. Let's see the, no, you are multiplying by 3 the previous term. No, it's not. Sorry. It's not this. Sorry. An is changing. You're multiplying the number of terms. So this will be geometric. We'll just look into this. You're multiplying what existed. You get the idea.
Oh, okay.
So if it is based on what exists, it is exponential and geometric. Is that okay?
Yeah.
Growth of bacteria, for example, right? More you have, then they are multiplying faster, correct?
Right. Yeah.
So it is dependent on what exists. Now this is dependent 3 times what exists. You get my point?
Yeah.
So what exists, that is why it will be exponential. Sorry for that. Okay, now continue. A, can you write down? Yeah, next.
3k plus 5, yeah. Part B, show that A3 is 9k plus 20. Okay. So just sub in n as 2.
Yeah, 3 times
A.
3k plus 5. Is it okay? Well, you have to sub in A2 into this, right? Plus 5.
That was smart, yeah.
Okay, right? So you plus 5. Is it okay? So now we got 9k plus 15 plus 5, which is 9k plus 20. Is it okay?
Oh, wait, I thought I had it, but then I don't. Did you sub in 3k plus 5 as k?
3k plus 5 as A2. So A3 is 3 times A2 plus 5. Is that okay? The value of A2 is 3k plus 5.
That was good. Yeah. I missed that step. Yeah, got it.
So we got this number, right?
Yeah. Okay.
See. Find the sum AR in terms of K. First 4 terms, R equals to 1 to R equals to 4. You have to find that sum. Is that okay?
So is the number on top, what does it mean again?
From 1 to 4. So we have to add A4 also.
Oh.
So find A4 also. It'll be easy for you. We'll do it like this time. So 3 times 9k plus 20, and then we'll add 5. And so we get 3 times 9 is 27k.
Okay, plus 60.
Plus 5.
Plus 5.
Which is 27k plus 65. Is that okay?
Yeah.
So you have to add all the four terms. So we need to find what is A1 plus A2 plus A3 plus A4. Is that
We
clear?
got all the values. Yeah.
That is the meaning of this sigma, right?
Oh, right. Okay.
Now, if you look into the pattern, so A1 is A1, right? Everything in terms of A, right?
Okay.
Because the terms, I mean, in terms of K. So write everything in terms of K because A1 is K for you, right? So K plus A1, A2 is 3K plus 5. A3 is 9K plus 20. And A4 is 27K
plus 65.
plus 65. So this is a combined series where you see that the number was, so you can add these numbers and get the needful, right? Then so you can add these numbers, right? And you can add these K values.
Take the like terms. Yeah.
Take the like and then do it. Is that clear to you?
Makes sense. Yeah.
So 3 of them, right? 1 times 3. So you see that the K values are increasing by a factor of 3, correct?
Yeah. Times 3 times 3. Yeah.
Times 3 times 3. We could have seen this also as, I mean, if you just keep them as 3 different factors, then you see 5 will go 4 times. We could split these terms and see another pattern also. What I'm trying to say here is that because we combine the terms, right? Do you see that?
Yeah.
We can't come, otherwise your series would have been K plus, let me rewrite this, right? 3K plus 5, right? And the next term will be 9K plus 15 plus 5. Do you see that series? And then 27K plus 60
plus 5.
Now you see the series, right? It makes more sense and it is easier to add if I extend this series to 10 terms, terms, not just 4. You get the idea?
Yeah, yeah.
So now you can see that you can keep one case separate. You keep this one case separate, correct? And this is a geometric times 3 each time. So this is geometric series, right? Is that clear to you?
Yeah, yeah.
And here also geometric series times 3, right?
But 15 times
4, right?
3. Yeah, but 3 is not 60.
Yeah, yes, this is different. Yeah. And this is constant. No, I mean, sorry for this. 5.
You mean 3, 9, and 27 is all times 3.
I mean, this 5 I will not write here. I'll write 5 on this side. That 5 is with this, right? 0 plus.
Oh, okay. So if we did like 4, it would just be 60 times 4, so 240.
15 times, yeah, it will go from here. Do you understand the next term?
Yeah. So times 4 times 4.
What I'm trying to say is, if you have to add 10 terms, in that case, do not combine as we did, but try to see the pattern.
Oh, okay.
And then do it.
Got you. Like you did there with the layout. Yeah, yeah.
With this layout. Is that
correct? Yeah. So I'll do that. Yeah.
Yeah, do that. So in such series, you can actually add them very easily because if I take 3 common, what do I get? I get 1, 3. I mean, 1, 3. These are 3 square, right?
1, 3, 9.
3 is power, right?
Yeah.
Yeah. So geometry.
Oh, 3 to the power of 1, 3 squared, 3 cubed, 3 to the power of 4 for the next one.
So you get many patterns when you solve such a question. Is that clear to you?
Yeah, yeah.
What I'm trying to tell you is that in sequences and series, some questions could be very complicated. Like we are getting into. We'll do this next class. We'll look into more examples based on this. Okay. The idea here is that, well, this was a small thing. Now, the question here is divisible by 10, they are saying, right? So if you look into the part, can you please read part 2 also?
So show that the sum of the 4 terms where r is still equal to 1 and a to the power of r, not to the power ar, is divisible by 10.
Correct. Divisible by 10, they are saying, right? So when you do this series, you'll find that because there are 4 terms, you'll have 4 number of 5s, correct? So 5 times 4 is 20, is divisible by 10, correct? Similarly, similarly, when you add this up, so it is like you'll take 9 plus 1, you'll get a factor. And so that will be divisible by 10. And even these numbers, which are coming in between, will be divisible by 10. So you can factor them out and show it. Well, when you add them, you know it is divisible by 10. When you add them, you get the result. So not a problem. 3 times 20, 3 plus 27 is 30, and 9 plus 1 is 10. You get 40K, right? So we know it is divisible by 10. 40K plus all those numbers are divisible, right? So you can always answer this because you can factor out 10.
10, yeah.
Okay?
Cool.
Anyway, we'll end our class here for now. And we'll continue from where we left in the next class. Okay?
Okay.
And also share with me any difficulties which you have based on this.
Will do, sir.
I hope that will be okay, right?
Yeah, this was super helpful, sir. Thank you so much.
Summarize in a minute, like what did you learn today?
Yeah, so we kind of went through exam questions, and I feel like the exam questions are definitely different from my book. When we started off, it was kind of straightforward with the arithmetic. We just kind of wrote, the questions were just subbing in the values that they gave into the equations that we know. So either finding the terms by doing a plus n minus 1d, or finding the total or the sum. Then when we found some questions, I think it was the geometric one where it said increasing by 3%. We discussed that there were different values of r. So the r in the equations that were in the book aren't the same as the r in which that question was trying to interpret it, because it was saying increase and not saying the ratio that the r was. So we found out that, because when I hurried through it, I put r as 0.03 when the actual value of r was 1.03. So it's important to just remember that the value of r can be different in the context. Then finally, we saw the log stuff, which is kind of straightforward. Whenever it says exceeds a certain value, you just need to think about inequalities. And then if you see powers and stuff, just immediately take log and it'll be fine. And then the final question was with that sigma. So we haven't learned that notation at school yet. So it was just nice to go through it and know what the top 4 means and how to add them on. So yeah, my main issue was just knowing when it's a geometric and when it's arithmetic, because obviously when you learn it's straightforward. One's just adding and one's multiplying. But when it's a lot of words in the question, you're like, is it geometric? Is it arithmetic? Because when there's unknowns, like we saw right now with all the K's, it's it's quite hard to know which of the formulas to use. So you helped me, to understand that really well.
Yeah. So just to add on that, so 2 terms in geometric series when we do the applications is growth rate and growth factor. So remember this, growth rate and growth factor. So the R is the growth factor, by which factor it increases in geometric series. Right. Is that okay? Yeah. And growth rate is the rate of increase which we saw in the population question.
3%. Yeah.
Perfect. Okay then, that was nice. Thanks. Have a great day.
All right. Bye, sir. Thank you.